Hello, welcome to our video solution to problem 6 from Superquiz 2. In this problem, we're given a force field, and we want to know what kind of work is being done by that force field moving an object along a path. Actually, there are two paths that we're going to be moving the object along. So the first answer to this question is, well, you need to integrate the vector field dot the differential for the path. So that means we're always going to be wanting to compute work in the following way. Work is going to be the integral over, well, whatever you name the curve of this vector field f, this force field, dot the differential for the parameterization for the path. So the first thing here, the C, tells us we're going to want to parametrize these curves. So first thing, we have a straight line segment. It's from 1, 0 to 0, 1, no problem. Let's parametrize that. And I'm just going to use a little subscript 1 here so that we can distinguish between the two parameterizations. So first, let's see, we're going from 1, 0 to 0, 1. So we start at 1 and we go down by 1 to 0. So minus t. And then the next one, we start at 0 and we'll go up by 1. So 0 plus t, 1t is just t. And we can let t go between 0 and 1 as we always do with line segments. All right, and as long as we're here, why don't we parameterize the other curve, which was, it's a quarter circle, has radius 1, centered at the origin, and again, it's going to go from 1, 0 to 0, 1, which let's just draw that really quickly so we understand that this is going from 1, 0, so that's right over here, 1, 0, up to 0, 1. So that's important because perhaps we might have gone from 0, 1 to negative 1, 0, or from negative 1, 0 down to 0, negative 1. But here we're really looking at this piece of the quarter circle. So the parameterization will just be, well, it's centered at the origin, so we don't have to shift. The radius is 1, so this is as easy as could be. Cosine of t, sine of t. It's even moving in the correct direction. We don't have to use like a negative t or anything. And the t, well, if we were going all the way around, we'd start from 0 and go to 2 pi. But we only want to go a quarter of the way around. So we're going to stop at pi over 2. Okay, so that'll be our we can maybe call this C1 and this could be C2. So let's call it work sub 1. This will be the work done in part A. So this will be the integral over C sub 1 of f dot dr sub 1. Now we want to write this as a regular old single variable integral, and so we're going to convert this from left to right. First, the C1 corresponded to this parameterization where t went from 0 to 1. Okay, now we need to take f and we need to evaluate it on this curve. So f was given by negative y comma x. So let's see, negative y, well, what is the y component? The y component on the curve is actually t. So we'll get negative t, comma, well, now we want x. What's the x component? The x component is 1 minus t. Okay, now we need to take the dot product with dr1. Well, what is dr1? So we're just going to differentiate each of the pieces of r1. So with respect to t, and the derivative of 1 minus t is just going to be negative 1. The derivative of t will be positive 1. And then we have a dt. All right, so now we just need to take this dot product, and that'll reduce our integral quite a bit. Well, let's see, that dot product should be pretty easy. Negative t times negative 1 is t, plus 1 minus t times 1, well, it's just 1 minus t. And if we add these together, well, look at that. The t's go away. How nice is that? This is just going to be a 1. And so we can just integrate dt from 0 to 1, which will just be the length of the interval, which is 1. Nice. Okay, how about the second one? So the work along curve 2 will be the integral along curve 2, f dot dr2. Well, this time we're integrating from 0 to pi over 2. And now we're going to evaluate f, which remember f, we'll just write that up here, f is negative y comma x. We evaluate now on this second parametrization, right? So negative y is no longer negative t, it's negative sine of t. And then the x, well, that's now cosine of t. Okay, now we take the dot product. We need to differentiate each of the pieces in R2. We'll get negative sine of t and cosine of t, all times dt. All right, well, let's see what happens when we take this dot product. Let's see, we get negative sine times negative sine. That'll be sine squared. Plus, then we get cosine times cosine. Ooh, that's cosine squared. Oh, how nice. Sine squared plus cosine squared. That's just 1. So once again, when we integrate, we're actually just integrating dt. So we get the length of the interval, which in this case will be pi over 2. How fortuitous.